Year 10, Lesson 3, Iteration. We're going to have a look at some exam-style questions on this topic. Have a look at this first question. So, the iterative process can be used to find approximate solutions to this equation here, a cubic equation. And what they've done is set up a flowchart to show us this iterative process. We start with a value of x, we work out the value of this. Is your answer to 4 decimal places the same as your value of x? Yes, then you've got an approximate solution. No, use your value to 4 decimal places as the next value of x and start again. So we are going to use this iterative process to find a solution to 4 decimal places of this equation, and we're given a starting value here of x equals 1. So x1 is equal to 1. Now, they haven't explicitly written it out like this, but this is our iteration formula here. So xn plus 1 is equal to 2 xn cubed plus 8 over 3xn squared plus 5. So remember how to set this up on your calculator using the answer button. And let's input x1 into this result here. So this gives me 1.25. So moving on to the next step, is your answer to 4 decimal places the same as your value of x? Well, no, it's not. So we need to carry on using 1.25 as our input value. So this then gives us x3, which is 1.22903 ... Now, it's telling me to round this to 4 decimal places. So to 4 decimal places, that's 1.2290. Now, is that the same as 1.25? No, it's not. Now, an interesting difference in this question compared to the ones we did in the previous lesson is it asks us to use our answer to 4 decimal places as the next value of x and then start again. So we're actually going to input this rounded value to generate our next value of x, x4. So this then gives me x4 is equal to 1.22886 ... Now if I round this to 4 decimal places, I get 1.2289. Now that's not quite the same as the previous value, so I need to make sure I use this value here as my value of x4 and input this into the iteration formula. So my x5 is then equal to 1.228860 ... So 1.2289. Now this is then equivalent to the previous value of x to 4 decimal places, so I'm going to stop there. Now, part B. By substituting your answer to part A into this expression here, comment on the accuracy of our solution. So what we're going to do is substitute our value of x, which is our approximate solution, 1.2289 to 4 decimal places, and we're going to substitute that into x cubed plus 5x minus 8, and we're essentially going to see how close our answer is to 0. So let's do this. So this gives us 0.00037889 ... Now, comment on the accuracy of our answer. Well, substituting this value here into the original equation gives us an answer that is very, very close to 0. And in fact, if we look at rounding that to 1, 2, or 3 decimal places, it would round to 0. So the answer we've got here is actually reasonably accurate because when we substitute it into the original equation, we get an answer that's very close to 0. Let's look at question 2. So an approximate solution to an equation is found using this iterative formula with x1 equals -1. So let's work out x2 and x3. Now there are some lines of working here, but you may not actually need to use these because largely what you're doing will be done with a calculator. There are only 2 marks available for this question as well. 1 mark will be available for x2 and 1 mark will be available for x3. There aren't really going to be any working marks allocated here. So inputting this into your calculator, you will find that x2 equals -0.3 and x3 is equal to -0.2027. Now, work out the solution to 5 decimal places. We're going to need more iterations. So x4 is equal to -0.200832. And if I round that to 5 decimal places, that's -0.20083. So remember, we have a separate column with the values we have iterated rounded to 5 decimal places. My next value, x5, is -0.200810, which rounds to -0.20081 to 5 decimal places. Let's keep going. x6 is equal to -0.2008097. So to 5 decimal places, this is -0.20081. So using the principles we're allowed to follow at GCSE, we have 2 consecutive answers which round to give us the same value to 5 decimal places in our iteration. So we can say that x equals -0.20081 to 5 decimal places. So question 3. Use the iteration here to work out an approximate solution to this equation here. Starting with x1 equals 1, give your answer to 2 decimal places. So x1 is equal to 1, x2. So remember, you can generate results using your calculator, use the answer button effectively, so it's really efficient and you can just keep pressing the equal sign. And we find that x2 is equal to 2, x3 is equal to 3.5, so x4 is equal to 3.83673. Remember to write down at least 5 or 6 decimal places here. And then, of course, we also want to round to 2 decimal places where appropriate. So x4 rounds to 3.84 to 2 decimal places. x5 is equal to 3.86413 ... So that rounds to 3.86 to 2 decimal places. x6 is equal to 3.86605 ... So that is 3.87 to 2 decimal places, which means we still need to keep going. We haven't found 2 answers that agree, 2 consecutive answers that agree yet. Here's x7, 3.87 to 2 decimal places. So this is the point at which we can stop. We have our agreement to 2 decimal places, so the answer is 3.87 to 2 decimal places, and this is our value of x.